Today's lesson is about review for vectors. For 1a, let OA vector is this. Vector AB is this. Where O is the origin, L1 is the line that passes through A and B. Find the vector equation for L1. Vector equation, which means R equals A plus T times B. Remember this form. This A will be the coordinates for the point on the line, or you could say that's a position vector. Since O is origin, therefore, this OA will be the position vector. You have 2, 1, 3 plus T times. This B stands for direction vector. AB is the direction vector. Therefore, we use 1, 3, 1. This will be the solution for 1a. For 1b, the vector 2p, 0 is perpendicular to vector AB. Find the value of p. When you see the word perpendicular, means the dot product of these two vectors equals 0, which means 2p0 times vector AB, that's 1, 3, 1, equal to 0. Then we solve this p. The corresponding component multiply. You will get the 2 plus 3p equal to 0. Therefore, p equals -2/3. Look at the 2a. 2 points P and Q have coordinates 3 to 5 and 7, 4, 9, respectively. Find the PQ. Since you are given the coordinates, therefore, we know easy. Ending minus starting. Therefore, PQ equals your ending will be 7, 4, 9 minus 3 to 5. You will get 4 to 4. For 2b, we need to figure out the magnitude of PQ. So we get the square root. 4 squared plus 2 squared plus 4 squared. You will get square root of 36 equals 6. For 2c, if PR equals this, find the angle between PQ and PR. So we're using the cosine theta equals. We do the PR times PQ. Then we do magnitude of PR times the magnitude of PQ. For vector PR, we can write down 6, -1, 3. Therefore, for magnitude of PR, you will get square root 6 squared plus -1 squared plus 3 squared. You will get square root of 46. Now we plug in. For PR, we have 6, -1, 3 times PQ, we got the 4 to 4. Then we have 6 times the square root of 46. For the top, the corresponding component multiply each other. 6 times 4, that's 24. -1 times 2, that's -2. 3 times 4, that's 12. Here's 6 square root of 46. You will get 34. 6 square root of 46. So we put into calculator, you will get theta equals 33.3 degree. Now let's go to 2D. Find the area of a triangle. We know the formula for area for triangle PQR. Area equals 1/2 PR times PQ sine theta. Therefore, you will have 1/2 times 6 times the square root of 46 times sine 33.3 degree. You will get 11.2. Hence, or otherwise, find the shortest distance from R to the line through P and Q. Let's draw the diagram. Suppose this is R. This is PQ. Here's this one is P. We already know this vector. That's 6, -1, 3. So the distance will be square root of 46. Suppose this is a PQ. This angle will be 33.3 degree. The shortest distance from R to the line through P and Q, I need to draw a perpendicular line like this. So we can do the SOHCAHTOA. Suppose this is H. I will get the H equals square root of 46 times sine 33.3 degree equals 3.73. For 3A, the vectors A equals this, B equals this are perpendicular to each other. Perpendicular to each other, which means A times B equals 0. Find the value of K. We will set up 4, 2 times K plus 3, K equal to 0. So these two multiply, you got the 4K plus 12 plus 2K equals 0. 6K plus 12 equals 0. Therefore, K equals -2. Given that C equals A plus 2B, find the C. So C equals A, here's 4, 2, plus 2 times K, here is -2. So we plug in -2 plus 3, that's equal to 1. This is -2. 1, -2. You will get 4 plus 2 times 1. And 2 plus 2 times -2. So we get 6, -2. Let's go to 4A. In this question, distance is in meters and time is in seconds. Two particles P1 and P2 start moving from a point A at the same time along different straight lines. After t seconds, the position of P1 is given by this. Find the coordinates of A. A will be the starting point, therefore it's 4, -1, 3. For B, 2 seconds after leaving A, P1 is at position B. Find AB. 2 seconds after leaving, which means we need to plug in t equals 2 to this equation. You will get x, y, z equals 4, negative 1, 3 plus 2 times 1 to negative 1. So you will get multiplication. Here's a 2, 4, negative 2. Then we adding. You will get 6, 3, 1. This will be the coordinate for B. You are given A, that is 4, negative 1, 3. Therefore, for AB, using easy, ending minus starting, which means 6 minus 4, 3 minus negative 1, 1 minus 3. So we get 2, 4, negative 2. Now let's go to 4C. We need to get the magnitude of a vector AB. Therefore, for magnitude of a vector AB equals 2 square plus 4 square plus negative 2 square. You will get square root of 24, means 2 square root of 6. For D, 2 seconds after leaving A, P2 is at point C, where AC, this is the vector for AC. Find the cosine BAC. Cosine BAC. We know that we have to get vector AC times vector AB. Then do the magnitude AC times the magnitude of a vector AB. Now we need to plug in. Vector AC given 3, 0, 4. Vector AB 2, 4, negative 2. Magnitude of vector AC, we need to work that out here. You have 3 square plus 0 square plus 4 square. You will get square root of 25, that's 5. So 5 times magnitude of vector AB, it's here, 2 square root of 6. So corresponding component multiply. You have 6 plus 0, then plus negative 8. You will get negative 2. Therefore, you get negative 2. 5 times 2 square root of 6. Reduce. You will get negative 1, 5 square root of 6. As we know, 1 over square root of A, we can write down square root of A over A. Therefore, for this square root of 6, I can write down square root of 6 over 6. Negative 1 and a 5 carry on, so that we got negative square root of 6 over 30. Let's go to 4E. Find the distance between P1 and P2 2 seconds after they leave A. We can draw the diagram. Suppose this is A. After 2 seconds, they go to B. After 2 seconds for P2, they go to the C. According to the given information, the length for AB, that's 2 square root of 6. Length for AC, that's 5. cosine A is given to you, negative square root of 6 over 30. We are looking for the distance for BC. That means P1 and P2, 2 seconds after they leave A. Suppose this is A we are looking for. We have included angle, this A, so we got to use cosine law. A squared equals B squared plus C squared minus 2BC cosine A. This is a B, this is a C. Therefore, we plug in A squared equals 2 square root of 6 squared plus 5 squared minus 2 times 2 square root of 6 times 5 cosine A. So we plug in. This one is 24 plus 25 minus, this will be 10, 20 square root of 6 times negative square root of 6 over 30. You will get, this is a 49 plus reduce 6 is a 12, then it's plus 4. So 53. This is A squared, that's 53. So A equals square root of 53. Let's go to number 5. Let U equals this and V equals this. Mn is real numbers. Given that V is a unit vector perpendicular to U, find the possible values of M and N. First of all, the unit vector means the magnitude of V equals 1. When you see perpendicular means dot product U times V equals 0. So we will set up the magnitude of V equals 1, which means I have M squared plus N squared. Then you do square root equals 1. So we have M squared plus N squared equals 1. For this U times V equals 0, you got negative 3, 1, 1. For V, you got 0, M and N equal to 0. The corresponding components multiply, adding together equal to 0, which means these two multiply, that's 0, plus M plus N equal to 0. So M plus N equal to 0. You get the M equals negative N. So that we can plug in here. M, I can do negative N squared plus N squared equal to 1. So we have N squared plus N squared equal to 1. 2N squared equal to 1. Divided by 2 both sides. You will get the N squared equal to 1 over 2. So we do square root for N. Don't forget plus or minus. So we get the N equals plus or minus square root of 2 over 2. Because 1 over 2 square root, I can write down square root of 1 over square root of 2. So you get 1 over square root of 2. That is a square root of 2 over 2. So we plug back in. You will get negative and a positive, because that's opposite of square root of 2 over 2. which means when m equal to positive, then n will be equal to negative square root of 2 over 2. Or we have m equals negative square root of 2 over 2, then n equals square root of 2 over 2. This will be the solution. Let's go to 6a. Consider the points, these two. Find the vector AB. We go to use easy. Ending minus starting. Therefore, for vector AB equals, we have B negative 9, 9, negative 6, minus 1, 5, negative 7. So your answer will be negative 10, 4, and 1. For B, let C be the point such that vector AC equals this. Find the coordinate of C. We know vector AC, it should be equals the coordinate C. Let me do x, y, z, minus coordinate for A, that's 1, 5, negative 7. Vector AC, we got 6, negative 4, 0, equals x, y, z, minus 1, 5, negative 7. We will set up the system equation. Let's look at the first row. We have 6 equals x minus 1. Second row, you have negative 4 equals y minus 5. Third row, you have 0 equals z plus 7. Minus negative 7 is a plus 7. So we have x equals 7 here. Y equals 1. Z equals negative 7. Therefore, the coordinate for C will be 7, 1, negative 7. Let's go to 6C. The line L passes through B and is parallel to AC. Write down a vector equation for L. Vector equation means we have to do R equals A plus T times B. A is the position vector, or the coordinates for the point on the line. For B, that's a direction vector. We are given the information this line is parallel to AC, which means this direction vector will be AC. So this line passing through B. So the position vector, we can use coordinate for B. You will get the R equals negative 9, 9, negative 6 plus T times vector AC will be 6, negative 4, 0. Let's go to 6D. Given that magnitude of AB equals K times the magnitude of AC, find the K. First of all, we need to working on the magnitude for AB. That is, this is the one, square root negative 10 square plus 4 square plus 1 square. You will get square root 117. So we simplify, you will get that 9 times 13, 3 square root of 13. For magnitude of vector AC equals square root 6 square plus negative 4 square plus 0 square. You will get square root of 52, which means square root of 4 times 13. That is 2 square root of 13. We can plug in this equation now. We have 3 square root of 13 equals k times 2 square root of 13. So we divide by 2 square root of 13 both sides. You will get the k equals 3 over 2 because we reduce this. Now let's go to E. The point D lies on L such that magnitude of AB equals magnitude of BD. Find the possible coordinates of D. Let's draw a diagram. Suppose this is A. And we have AB is here. And AC is here. We know the AB equals 1.5 AC. That's the length. Then for this L, it will be parallel to AC. So we draw like this. We need a D. It's AB equals BD. So we are supposed to get 2 answers for D. And we said these 3 equal to each other. Since this AB equal to 1.5 AC, and this AB equals to BD, so we have BD equal to 1.5 AC. According to this diagram, we do know the BD that's parallel to AC. Therefore, means the same direction or opposite direction. I can write down the BD equals positive 1.5 AC, or BD equals negative 1.5 AC. For the first one, suppose the coordinate for D that's X, Y, Z, because using that EZ, ending minus starting, you minus the coordinate for B that is negative 996 equals 1.5. AC is given to you. That is 6 negative 40. You can set up X plus 9 equals to 9. So we have X equals 0. Y minus 9 equals to 1.5 times negative 4. That's negative 6. So Y equals 3. Z minus 6 equals 0. So you have Z equals 6. For coordinate for D, it will be 0, 3, 6. Now let's go to this part. We still have X, Y, Z minus negative 9, 9, 6 equals negative 1.5, 6, negative 4, 0. Therefore, X plus 9 equals to negative 9. So you have X equals negative 18. Y minus 9 equal to 6. Y equals 15. Z minus 6 equal to 0. So Z equals 6. So you get another coordinate for D that is negative 18, 15, and 6.